taking the Y position plus R dot height, and we're doing the same thing going to the right. So these two lines will be parallel to each other, this top one and this one here. Yeah, that should draw the line across the bottom. And then we want one starting at the top left corner, going straight down, so we want the thickness to be the width, and we want to use the height. That'll draw another line straight down, parallel to the second one here. We can save our extensions class and go back to Monsters6, and we'll have to change this to a small s. Oh, what am I doing here? I didn't put sprite batch here. There, X is that. So now we're showing the player's box. Now we'll start looping through the monsters and draw their colliders. While I is less than the number of monsters, I plus plus. If not monsters I dot dead, then we'll show it. Monsters I draw collider. Pass in the sprite box or sprite batch and the texture. And that's it for that. Go into monsters again, into draw collider, and determine if the monster is actually on the screen. Just go up to draw here and copy this and paste it in here. No point in drawing a collider if it's not something you can even see. And we'll draw. First we'll get that top left corner of the bounding box of the actual monster on the screen. So left equals the screen position of the monster, which is the center of the monster, plus the offset to that corner, which is bounding box.x. And we want the top left corner, so say screen position.y, bbox.y. We can set that pixel value in here too again, say rectangle. We can copy that out of the other one actually. So I'm copying out of draw colliders and Monsters6, going back into monsters, just pasting it in here. We'll want to show the monster's vulnerable box first. We'll use sprite batch draw rect lines, texture, pixel, new rectangle, cast integer to the left. Same for the top. We'll use bounding box width and bounding box height. Color dot white, or whatever color you want to use. We'll probably use red for the attack box. So we'll change top to be the screen position dot y plus attack box dot y, and the left is going to change depending on which direction he's facing. So we'll say if not flip. So normally, in other words, we'll say left would be the screen position dot x plus the attack box plus attack box dot x. Offset top left corner of the attack box. If he is flipped, then we'll have to do this a bit differently. Say left, top left corner is going to be screen position dot x minus attack box dot x minus attack box dot width. Now, as you may be aware, the attack box position is already a negative number. Well, not necessarily, but that's going to flip this in the other direction, and it's got to be relative to. It's kind of tricky to explain this. I'd almost have to show it to you on a piece of paper or something. But this basically just flips it so that the top left corner is still on the left side, because that's where we want the top left corner, not the top right corner. I just added this comment in here for console right line to show the left and top coordinates, attack width, height, all that stuff if you need to see it in the output. Just keep in mind you don't ever want any console right line stuff turned on in a release of a game, because that's going to slow down the game. Sprite batch.draw rect lines x pixel new rectangle, same thing as before, not quite exactly the same. So top left again, attack box dot width and attack box dot height. So that's the only real difference there. And we're going to use color red to see that it's the attack box. Now we'll go into game 1, that's where I am right now, and you'll see a section. I'm just going to label it. I'll say edit mode only, or edit. So this is for editing and diagnostics and stuff. Section here. And we'll do a number if show underscore player underscore collider and number end if. So this here will only show up if we want to show colliders, and that's players or monsters. I just put show player collider. You could say character collider, or it's up to you. And we're only going to concern ourselves with seeing colliders when the player is on the map. So the camera might be shooting towards where the player is when you first start it up, in which case we don't really need to bother. Before we do anything though, let's actually define that. We'll go to the very top, and before usings, the very top, we'll put number define here, because you have to put all your definitions right at the very top. Show player collider. And like I said, that's for players and monsters. Whenever you want to turn this off, just comment that out. So you'll have to make sure to remember that. Hit Control F, show player, there. The player's location is its map location, greater than A1, which is within the drawing region. If you check out map, A1 to A2 is left to right for what's drawing for tiles, and B1 to B2 is top to bottom for which tiles are going to be visible. and the player's location. So if it's greater than the left side of the section to be drawn, less than the right side of the section to be drawn, greater than the top part of the section to be drawn, and less than the bottom, then you know it's within that region that's going to be drawn. So we'll say collision detection position, cd pose, is new vector 2. We can use SX, which is the screen map position. That's the top left-hand corner of the screen. Like if you look in the map class, I got this comment right here now. It says start coordinates top left of tiles to draw on screen. So that's the physical location on the screen where it starts drawing the tiles as it scans horizontally and vertically through them. So like the actual screen pixel position. And that might be partly off the screen up and to the left for where it starts. So just so you understand what that is, back to game 1. So we're making a new vector for collision detection position for the player. So that's that position on the screen plus 64, which is the size of one tile, times how many tiles to the right from that corner tile. So that's going to be player.location.x minus map.a1, because those are the world map locations. We want the relative amount, so we want to know what the tile distance is, how many tiles to the right. Times that by 64, that gives you the pixel offset from that screen top left coordinate where it starts drawing the tiles. It's a little confusing, I know. Plus 64, same thing, the top position of where they start, times the size of a tile, or the size of a tile times the distance in tiles from that position. So map.b1. That gets the collision position for the corner, the top left corner of the player. We also have to add in the map scrolling offset because that keeps changing from 0 to 64 as the map scrolls. So right batch, draw tiles image, and on my tiles in the top right hand corner I have a rectangle with an X that I'm going to use to show where my character is. So you might have to use a different rectangle source or some other image if you want. Mine's at 960, 0, 63 in width, 63 in height. We'll try to colorize it as yellow. I think it was red, so that won't really show up. If you use white though, you can use any color here. 0, scale 1, sprite effects none, clear depth 0. And then I'll say Monsters6, monster system. We don't have one of those yet. In game 1, we're going up to the top where our variables are, fields. Just before construct, we'll add a section in here for monsters and NPCs, non-playable characters, if you have any. Monster system, Monsters6. And we can use Monsters6 too for NPCs if we want, and just make it so that they don't do damage and they can trigger other types of events, but I'd probably put it in its own class. I mean, if your game's going to get more complex, then you might want your own class for that. Now scroll down to load, and right after player we have this create Monsters6 section here. So let's do that. Monsters6 is new monster system, content, quad batch, map, player, and we'll say Monsters6.load level 1 content. So that'll load up our monsters. And now that we have a monster system, our editor is going to want to be able to put monsters down. So we'll put Monsters6 here, and then we'll go over to our editor and modify it. So it can take monsters. Go over to editor, and right after player, we'll add the Monsters6. Monsters6. In its constructor, we'll want to be able to pass in Monsters6. We'll just call it monst. And at the bottom of this, we'll add Monsters6. Yeah, Monsters6 is equal to monst. And we have a way to add monsters to our monster list, but we don't have anything in our editor to insert monsters. So we'll say void insert monster, given a monster type that we want to insert, and a world coordinate where we'd like to place the monster. And using our monster system, we'll add monster, the monster we want to add based on its type, at the world coordinate. Seems rather redundant, except we haven't added it to the map yet. So we'll have to add set monster, and we already have this. And all that does is apply a monster type to a tile. We'll go down to the editor update so we can delete and add monsters. If the user presses delete over a monster indicator on the map, it should also try to delete the monster. So that'll just check to see if there's a monster there, and if there is one, it'll delete it. And we'll want to be able to add monsters, so we'll go down a bit. And right before place player, let's add a section called add character or monsters. We'll say if not tile, mp.location.x. So if it's not a solid tile, then we're going to allow us to add a monster at that location. Just a slight precautionary. We don't want tiles, or we don't want monsters being initialized stuck in a wall or anything like that. So if key press, keys D1 is digit 1, which is the number 1 on your keyboard. Insert monster, get monster type, and we'll insert the monster for the first number. and we'll copy that. And for D2, second number, we'll allow it to insert the Hellcat. And we'll go into draw locators, and let's make it so we can actually see the monsters on the map when we add them, so we know what type of monster it is. So we'll say Monsters6.draw. And it'll just draw that monster at the world coordinate on the map. And we could already save and load monsters. Let's go back. In game 1, now you can see that where it says init editor, Monsters6 is no longer underlined, so that's all right. Go down. And in play mode, we got player collision detection response, and then we got the bouncers, and then we got the player set animation. We still need the monster AI and animation. So Monsters6 update and give it game time. In editor mode too, we'll want to update the monsters so they'll appear on screen correctly. Date, game time, and we don't want to update the AI for that, so we'll just say false. Then in game 1 draw, we'll also want to draw the monsters from here, so we'll use Monsters6 draw. So now both monsters and player sprites are drawn on the sprite map, or on the sprite target, which is used in the reflections. So back down to that show player collider thing in the edit mode, or under the edit mode thing, say Monsters6 draw colliders. Almost forgot to do that. And we'll send it tiles image because that has our white pixel on it that we can use to draw those rectangles. Okay, did a build and a run, and it says that image file name, you can see here is monsters. Couldn't find it, so I'll stop and I'll change that to Monsters1 because I think that's what I named it. So yeah, the combined image is Monsters1, and that's without a capital. If we go into the bin folder that has the monsters.txt, that's your project name, bin, desktop.gl, any CPU, debug, or release, depending on what it is. And I changed this to monsters PNG because I thought that's what I was going to name it, but actually called it monsters without a capital and 1 PNG, so I have to change it back. So save that, and now it should work, except for one fatal flaw. We haven't added it in our MonoGame pipeline tool. So we'll go edit, add existing item, click on Monsters1 PNG, and add, and save, and build. And we'll stop this again. So we got colliders turned on. You can see where the character is. The fire particles are going over top of everything. Not seeing the monsters. So I have to check something. Okay, I had a hunch that number of monsters is 0, even though I set the map to have monsters in it. And I put this in here just to check it. And yeah, it's 0. So I gotta figure out what's going on here. Oh, I realized what happened here. I saved out the level, but when we load the level back in, it's not adding the monster back to the map. So go to load level in editor, and down here where we pre-process tiles, after we load them, got this little spot here where we put if the monster start is not equal to none. So if there is a monster at this tile, or supposed to be one, let's add a monster at this location. I'll say Monsters6.add monster, monster start. So that's the type, and then we need the world position to add it. So convert tile to world, or point A, B, that's the current tile that's being processed. Need an extra bracket here. Okay, that should do it. I was just doing some testing and I realized that if you allow creatures to be updated and shown that are way off screen, it can cause problems with panning amount because your calculations go to great extremes and they start to pan beyond the allowable range. So I put these math helper clamps on here hopefully to fix that. I'm going to go into monster jump and I'm going to change this from this to if not grounded, because not all the monsters have a jump. Okay, I paused it for a moment because I just wanted to debug a few things. One little imperfection I noticed here, if you go into the player.jump class, go into the player class and go into motion.jump, in that case where you see this will say and grounded, I changed it to last grounded. Not essential, but changing this to last grounded seemed to make the response a little tiny bit better. One thing I would do in the future, just to make the jump response better as you're falling off of tiles onto ones below it, sometimes when you hit the edge of a tile, as with most games actually, the response doesn't happen immediately, so you can actually fall off the edge because you haven't quite actually hit the ground, even though it looks like you have. So what I would do is change it so that the grounded status will actually activate if he's close enough to the ground. So if he's only a few pixels off, give the player the benefit of the doubt and give him a grounded status. One way you could do that, for example, is you could just go into one of these, well, you do this in all of them, and copy this line, for example, and change this one, first of all, to say +10, and then you'd have to give it another nested if section here without +10, and give it a grounded status first. So if it's within 10 pixels of the ground, we'll allow him to jump again. That actually might be a bit generous. We'll say 5. Then we're going to allow him to jump again. Otherwise, he actually has to be on the ground for any of this other stuff to happen. Okay, so I just went ahead and created this going down tile test because this was starting to take up too much space. So I made one method that would take care of all of that. And what I did was I copied that code. It's pretty much the same, except I got this constant in here for bounce velocity, and I got the offset y in here instead. And what's different in here is I added this condition here, which is exactly the same as this one, which you had before, except I'm checking an extra 10 pixels. So I'm giving it a 10 pixel tolerance. So if the bottom of the feet plus 10 is going to cross into the tile below it, then we're going to allow the player to jump by saying that grounded is true. We're not going to do anything else relating to the collision detection though, unless his feet are actually touching the ground. And this stuff is new. What I did was I by default have h offset 0, but if something is passed in, then what it does is if it's not 0, like if it's greater than 0, it does a check less than with h offset added. So that's for that test, like if this was, I'll just show you down here. For example, for x minus 1, checking the tile to the left, I give it an h offset of 84. For x plus 1, checking the tile to the right, I give it an h offset of minus 20. So what that does is it allows the player to kind of stand on the edge before falling off. So if they're within this extra horizontal threshold amount, 20 pixels, so 64 plus 20 for the x minus 1, if this is x minus 1, so if this is less than x minus 1 times 64, or x minus 2 if you were doing it that way, then it'll set h offset to 0. When h offset is 0, it'll go ahead and execute this. Normally h offset is 0 for when you're not using x plus 1 or x minus 1 by default, but if you're using x minus 1, you want it to check this, so you'll have h offset set to 84. If that's okay, it'll set this to 0 and it'll go ahead and do this. And if this is less than 0, so minus 20, then if it's greater than that, it'll set it to 0 again and then do this. Otherwise, you just keep in mind that your x or your y are going to be x plus 1 or y minus 1 or any variation of those, and it's the same sort of rules. So I can get rid of this now because that's the only place it's used. And here we go, xy, x, y plus 1, x minus 1, and y with 84 offset, x minus 1, y plus 1 with 84 offset, and x plus 1, y plus 1 with minus 20 offset, x plus 1 with y and minus 20 offset. So those are your 6 tests. We can get rid of this other stuff. And since on spikes is global, we don't have to worry about that. So that greatly shrunk this section of the code. You could take it even further and do stuff with moving left and right, although those are fairly simple, so I'm not worried about that. So we can copy this code out of here actually and put it in Monster and kind of shrink that code a bit. I'm going to put it inside the world collisions region. Change bounce velocity to minus 20 instead of 21, and instead of player feet offset, we'll change these to bottom. Change this to monster jump. And for the monster, it's not critical if he's able to jump the exact second he touches the ground. So we'll take this section out, and we can pull this back to here. Use Alt Select. And we can start adding our tile tests in place of these ones. X minus 1y, x minus 1, y plus 1. Then we'll go x plus 1, y plus 1, and also x plus 1, y. And we're not using bounce velocity in here anymore, so comment that for now. Actually, just to be safe, we could take this right out of here, put it here, that way we can always use it in the future, elsewhere if we need it. It's a constant, so it's not going to matter. Alright, the tests seem to be working good. We can take these out. So I had a few bugs that are really important that I show you. Where I had the clamps, I was just saying this before. I don't know why I was assuming that it would change these, but yeah, it's the return value from the math helper. You have to assign it to that. So if you don't have these, this y1 equals, y2 equals, x equals, it's not going to work. Same thing too in the sound. So before in here, I just had these clamps like this. That's not going to work. I mean, it'll compile, but it's not going to change pan x to be clamped. So then you could end up with some errors because these values could end up out of range. And I decided to put these clamps down here, and being that I did that, I can actually just get rid of these. And I think that would be okay. So it seems I'm still getting stereo panning, and it's working exactly as expected. Looks like there might be something wrong with collision detection though. Oh, I know what it is. I forgot something. Yeah, the collision detection for the monsters wasn't right. I just noticed I forgot to put the horizontal offsets for these. So that'll be 84 for 20 pixels to the right, so plus 64 normally. That'll be 84. And then for these, it would be minus 20. Now it should work correctly. Let's take grounded out of here, and we'll place it in here with velocity equals 0. I noticed another bug that's causing the monsters to kind of wobble up and down. I didn't times this by rescale Y here, and instead of 11, this should be 30, and the one for Hellcat should be 20. It's all dependent on what kind of distance you want from the root to the bottom of the character. So I'm subtracting that amount, so you just kind of have to play with these numbers until you get the character so that they're standing in the right spot and so they don't start wobbling up and down. You might notice that our reflection is kind of downward, so let's try to fix that so it's upward more. The weird thing is I don't remember changing it to this. What I had this is 5. That would be about 50 pixels. That'd be about 100 pixels, roughly. That looks better. We got both the reflections going. All the sprites are reflecting. I shoot fireballs. You can see the reflection from that side. This way you can't really see as much, because it reflects to the right of wherever it is. A couple more little improvements to the sound. If the stereo panning is for a sound that's really far off screen, like if it's less than or equal to the negative maximum value and the positive maximum value, then we'll set pan Y, which is the main volume for the sound, to 0. And then in our monster class, for example, if pan Y for the sound is greater than 0 for landing, then we'll set that sound. I also added the panning characteristics of the landing sound here now, and I added this in here to make sure that it's not re-triggering the sound. The velocity has to be over a certain amount at least. We could even say 2 before it'll make a landing sound. We could do the same with the player also. And if we go up to jump, you can see I added the same thing here too.